So we are given two orthogonal matrices A and B, and we need to indicate which of these three statements are true. So before we start, let's review the properties of orthogonal matrices. So for example, if we have an orthogonal matrix A, then A multiplied by the transpose of A equals the transpose of A multiplied by A and equals identity matrix. Also, the transpose of A equals the inverse matrix of A. Well, now let's try to look at our first statement, that the determinant of the A transpose times A plus B times B transpose is equal to the determinant of A transpose plus B transpose. We need to understand that A transposed, so this is part one. Part one. A transposed times A plus B times B transposed is not equal to A transposed times A times B transposed plus A transposed times B transpose. So we cannot open our parentheses like this. That means that the determinant of A transposed times A plus B times B transposed is not equal to the determinant of A transposed plus B transposed, because we know that A transpose times A is identity matrix, B transpose B times B transpose is identity matrix, so we get that this is equal to B transposed plus A transposed. But again, so the determinants won't be equal because this is not an inequality. This is not an equation. Well, let's move. So the first statement is incorrect. Let's move on to the second statement. Since we know that A transposed equals the inverse matrix of A, that means that A inversed plus B transposed equals A transposed plus B inversed. So that means that the determinant of A inversed plus B transposed equals to the determinant of A transposed plus B inverse. So the second statement is true.